Here's another distance from a point to a line problem. So the distance from y equals 5/3 x plus 9 to the point p equal to 6/2. And so we're going to go through the same steps as the other one. First, you're going to determine the equation of the line L that goes, that's perpendicular to L, that goes through the point 6/2. We're going to call that line K. Okay, so if you want to try that first, go ahead. Here is the solution. So the slope of line L is 5/3, which means the slope of the perpendicular line is -3/5, the negative reciprocal. Okay, so the equation of line K is going to be y equals -3/5 x plus b. We're going to sub in the point 6/2 to find b, and not as nice as the last one. We end up getting b to be 28/5. So this is the equation we get for line K, the line that is perpendicular to the given line. And so we're going to look at a graph of these here now. So here is the point P, which is 6/2, so 6 on the x-axis, 2 on the y, so there's 6/2. And here is the line L. So line L was 5/3 x plus 9, so you're going to start from 9 on the y-axis, and you're going to go up 5 and over 3, but because that it's maybe too much, I'm going to go down. I'm going to go down 5 from 9 to 4, and then back 3, and I get that point. Okay, I use those 2 points there to graph my line. Now I want this distance from P to line L. Okay, so this distance here from P to line L. And so we need this point here. We need to figure out what that point is. So we're going to extend this line segment to line K and find the intersection point of these two lines. That'll give us point S. Okay, and so that's the next step. So we got the equation of line K. Now we need to find this point S, which is the intersection point of K and L. So in order to do that, we're going to convert the two equations into standard form. It makes it a little bit easier to work with, I think, in this case, because there's fractions. So standard form for line L is this. Standard form for line K is that. I'm going to pull the constants to the other side so we can do elimination. Okay, so the next part is elimination. And to do elimination, I'm going to eliminate the x's first by doing 3 times line L and 5 times line K. So 3 times that'll give me a 15 there, 5 times that'll give me a 15 there. These are the numbers you get. I'm going to subtract because they're the same sign, and I get y equal to 13/2. Okay. Now I'm going to eliminate the y's so that I can get x. Okay, so I'm going to do 5 times L, it's 3 times K, and I'm going to add the two. Add them, and I get x equal to -3/2. Okay. And there's our intersection point, okay, which is F. Okay, so now we can find the distance from P to S using the distance formula. Okay, so let's take a look at this now. Right here, here's the distance formula. So distance from P to S, xs minus xp squared plus ys minus yp squared, all square rooted, just Pythagorean theorem. Okay, so the xs is -3/2 minus 6, which is from the point P, 13/2 from S, minus 2, which is from point P. You work that all out and square it, and you get this nice answer of root 153/2, which is the exact value, or approximately 8.75.